Hello, good evening. All right, we'll continue a little bit more on problem solving using geometric progression. All right, okay, now the question is, okay, a particle moves 30 meters in the first minute, 20 meters in the second minute, and 40/3 meters in the third minute. Okay, now the question says, what is the limiting distance traveled by the particle? Okay, here if you notice in this question, we have said my first movement, a particle moves about 30 meters in the first minute, so I'm assuming that's my T1. Okay, T2, in the second minute it moves 20 meters, and in the third minute it moves 40/3 meters. All right, okay, so that means here I'm assuming that it is actually decreasing. The value of m, if you notice, is decreasing. So we guess eventually the particle is going to move slower and slower until it actually stops. All right, and we do not know when it's actually going to stop because they've not given us the last term. So in this case, okay, what we can actually do is, okay, I'm going to get what's my first term. Okay, so that means my A is 30. I can actually calculate my R. My R is 20/30, which gives me 2/3. 2/3 means R is less than 1. Alright, we do not know what's my N because it just said limiting distance. So the particle can actually go on and on and on until it actually stops, right? Okay, so for that case, because I do not know my last term, I'm going to assume this as this case, where S is equal to infinite. S infinite means my N can actually go on. So this is actually A, 1 minus R. So A is actually 30/1 minus 2/3. So this is actually 30/1/3, which gives me 30 times 3. So the answer is 90 meters. Okay, so that's your limiting distance. So we take it to S to infinite. All right. Okay. Now, another question. All right, it is randomly picked. Okay, so now in a GP, the sum of the first 5 terms is 11. So I'm doing this first 5. T1, T2, T3, T4, T5. Now this S here is 5. Okay, now the next 5 terms is 11/32. So the next 5 terms, I'm assuming is 6, 7, 8, 9, 10. So that 5 terms, the sum equals to 11/32. Okay, the question is find the common ratio, find the first term, and the sum to infinite. Alright? Okay, so that means here, what I'm going to do is, to get my first term, A, this one, so this is AR. In this case, we do not know whether it is whether my R is going to be greater or less than 1, but assuming that it's 11/3, looks like it's decreasing, so therefore I'm going to assume that my T2 is actually less than T1, T3 is less than T2, and so on. All right, okay, so for this I'll do this. So the first term is A, second term is AR squared, AR cubed. So this is 1, 2, 3, 4, 5. Okay, this one equals to 11. All right. Okay, now this is my next term, T6 up to T10. All right. So you can also do the same thing. So here, if it's T6 is A R n minus 1. So this is 5 plus 6 plus 7 plus 8 plus 9 plus up to 10. So this is AR to the power 10 minus 1, 9 lah. So this will be 11/32. Right? Okay. So now the next thing you can do, this is one method, you can actually use the problem, simultaneous method to actually solve it. Alright? Or what we can actually do is we can actually use the sum. So my sum will be, if I'm using this first part, so this is S5. I do not know my A. Okay, I'm assuming my R is less than 1. So this is my R to the power 5 over 1 minus R. Okay, so here I get 11. Alright. Okay, now the next one is S10 minus this, because I only want 1, 2, 3, 4, 5. So S5, this is actually 11 over 32. So S10 will be here. Or what you can actually do is, okay, we won't use this method. I'm going to take it from here to here. So this is my first term. So my first term is S. I also have 5 terms. My first term actually is actually t to the power of 6. That means this is AR to the power of 5. 1 minus. R should be the same because it's the same progression. So I'll go with this. Okay. Over 1 minus R. This is actually 11 over 32. Alright. Okay. So that means now what I can actually see here is, you see this part and this part looks the same. Alright. So that means from here I can actually say 1 minus R. Okay. This is actually 11 over A. From here I just move the A down. So I'm going to sub this inside here. Okay, so when I do my substitution, I'm going to substitute inside here. So this one becomes A R to the power 5. Now this whole thing is actually this, which is actually 11 over A. Okay, this becomes 11 over 32. Okay, so what's going to happen now is this will cancel off. So here I get R to the power 5. Okay, this 11 and this 11 will cancel out. So I actually get 1 over 32. Okay, so R to the power of 5, I can actually bring this up. This is actually 2 to the power of 5. Okay, so that means from here I can say that my R is actually 1 over 2. So if I can get my R as 1 over 2, I come back here using this formula. Okay, what we can actually say is S5, this is A, 1 minus R to the power of 5, 1 minus R. This is 11. This is from here. Alright? Okay. R is half. So when R is half, A, 1 minus half to the power of 5, 1 minus half, this is 11. Okay, so we solve for this. So A, this is 1 minus 1 over 32. Okay, this one comes up. So this is 11 times half. Okay, so here A, this will be 32, means this is 31 over 32. This is 11 over 2. Okay, so A will become 11 over 2 times 32 over 31. 16. So A becomes okay, so A is actually 31. Alright. Sorry, yeah, this is not 31. Okay, so we get 5.677. Okay, so we get about 5.677. Okay, so that's my first term. So now to find my sum to infinite, the last part. So sum to infinite is A1 minus R. Okay, A is 5.677 over 1 minus R is half just now. So 1 over 2, so this is times 2. So we get 11.355. Okay, so that is sum to infinite. Alright, thank you.